So what will naturally follow geometric sequence is geometric series. So we're going to learn another formula for how to add the terms in a geometric sequence. So a geometric series, the sum of the first n terms is the first term times the quantity 1 minus the common ratio to the nth power, all over 1 minus the common ratio. So, of course, let's see how this works with a simple series first. 5 numbers, of course, we could easily add them up, but we're going to practice our formula. So the sum of the first 5 terms is the first term times the quantity 1 minus the common ratio. We can easily see we're multiplying by 2 to the nth power. We're summing 5 terms all over 1 minus the common ratio. Punch this into your calculator, and actually the way that it's formatted here, you need a double set of parentheses, but in actual order of operations, it's going to multiply and then divide, which is just fine. So you need parentheses around, let's see, get another color, around your numerator and around your denominator, but you actually don't need the big parentheses around the whole expression. So I got a sum of 62, which again, we can easily see when we add those numbers up that we get 62. Next, we're going to practice both the geometric sequence formula again, as well as the sum formula. So to find the 10th term in a geometric sequence, we take the first term times the common ratio. This one isn't quite so obvious. So another way to find the common ratio is to take term 2 divided by term 1. And of course I would simplify that, dividing them both by 6, we get, let me write the answer instead of what I'm dividing by, 3 halves. So our common ratio is 3 halves to the n minus 1 power, or to the 9th power. This time I got a decimal, because as we can see our third term is already odd, so when we multiply it by 3 halves, we're going to get a fraction. So I rounded to 3 decimal places. I got 461.320 for my 10th term. Now, we don't need the 10th term to find the sum of the first 10 terms for the geometric series formula, which is really nice actually that we don't need that final term. So it does simplify things a bit for us. So the sum of the series, again, is the first term times the quantity 1 minus the common ratio to the nth power, all over 1 minus the common ratio. So for this, what I did when I punched this into my calculator was I just turned the 3 halves into 1.5 because I know 3 halves as a decimal pretty easily. Otherwise, if it was kind of a funny fraction or ratio there, you would have to put those parentheses around the fraction as well as around the numerator. So if you want to try that out in your calculator, I got 1,359.961 for my sum. And of course, we're going to review our sigma notation. So this time we can tell that it is a geometric series because we have the first term. It looks just like the explicit formula. The first term times the common ratio to the n minus 1 power. In this case, we used k for our variable instead of n, but it's the same thing. So in order to find the sum, all we need is the first term. So we substitute k in as 1. 4 times 2 to the 1 minus 1, or 0 power, which is 1. 4 times 1 gives us 4. So the sum of the first 5 terms is the first term times the quantity 1 minus the common ratio, which is 2. We can tell that from our formula, to the nth power, all over 1 minus the common ratio. So this time I got a sum of 124.